In this lecture, we're going to learn about linkage. And linkage is a property associated with names in your C++ program. We're going to be exploring this in the context of variable names and function names. And this property is going to control how visible the name is across translation units. Okay, so suppose we have a function here, and inside our function, we have a variable declared inside. We have the age variable, the value is 6, and the job of this function is to print this out. If you look at this age variable here, it's really only accessible inside this function. You can't even access it from the outside of this function here. So we say that this variable, the name for the variable here, this age here, it has no linkage. And what we mean by that is that it really isn't accessible from anywhere in the global scope of the file where it is, or even in other translation units. So it has no linkage. That's what we say here. If we look at another example here, we have a variable, for example, it is declared in some file. This is a constant variable, and by default in your C++ program, const variables are going to have internal linkage. What we mean by that is that they can only be accessed or used in the translation unit where they were declared and defined. If you try and set up another variable of the same name in another translation unit, you're not going to be picking up the name of this variable here. You're going to be setting up a completely different variable. And we're going to see an example of this once we hit Visual Studio Code in a minute. But note that constant variables like this have internal linkage by default. And what we mean is that they can only be accessed and used from the translation unit where they were declared and defined. So this is another kind of linkage we can have in C++. The first one is no linkage. We can also have internal linkage, and it is what we just learned about in this slide here. Another kind of linkage we can have is external linkage. And a good example for this is a global variable, which is not const. This is going to have external linkage by default. And what we mean by that is that this variable can be accessed and used in different translation units than the one it was declared and used in. So for example, if this was declared in file 1, it is possible to access and use this variable in a separate translation unit. And this is really cool. And this is what we mean by external linkage. Functions also default to external linkage in C++. You can declare the functions in one translation unit and use them in a separate translation unit. And we have seen that at multiple occasions. So in C++, we have a lot of options for linkage. We can have no linkage. For example, if a variable is local to a function, we can have internal linkage. And what we mean by that is that this name is not going to be usable or accessible from other translation units. We can have external linkage, and what we mean by that is that the name can be accessible and used in other translation units, separate from the translation units where it was declared and defined. We can also have module linkage, but we don't have enough tools to really understand this. So in this lecture, we're just going to focus on the three options: no linkage, internal linkage, and external linkage. Okay, so let's recap what we just talked about here. Function local variables have no linkage, so they can't really be accessed even from the outside of the function. If you try to do that, you're going to get a compiler error. Const global variables have internal linkage by default, so they can only be accessed and used from the translation units where they were declared. Non-const global variables have external linkage by default. They can be used in other translation units, and we're going to see a few examples of this in a minute. Functions have external linkage, and they can be used from the translation units different from the one they were declared in. Now that you have an idea about what linkage is, again, it is a property associated with names, for example, variable names, function names, and this property is going to control how visible the name is across different translation units in your C++ program. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is Linkage. We're going to grab our template files. We're going to copy them pretty fast and put them in our folder here. And we are going to open this little guy in Visual Studio Code. This is going to give us our main CPP file. We can clean it up a little bit. And we're going to close the sidebar here because we don't need this by now. So the first thing we're going to look at is no linkage. And the way to set up this example, we're going to set up a simple function. We're going to say some function. And inside the function, we're going to set up a variable, call it age, and initialize that with 34, for example. This could work. And what we're going to do is print this out. We're going to print the age, but we're also going to print the address of this age variable. So we're going to say address of age. We can say that in our C++ program. You already know this. And we're going to print the address of age here. And we're going to say stdndl. And I don't know why we have this problem here. Why do we have these squiggly lines? We don't have a pair of parentheses here. That's the problem. So we can make this work now. And if we try and compile this program, it is going to compile. But before we do that, we're going to say some function. We're going to call it. And it is going to print what we see here. Let's do that. We're going to build our program with GCC. And you're going to see that the build is good. We can bring up a terminal and play with us a little bit. We're going to run rooster, and we're going to see our age to be 34. And the address of this variable in memory is what you see right here. But we can separate these guys by putting a space here so that the output is better. Let's build again. To make sure this is working, we can clear and run rooster. Now we have the age here, 34, and the address of this variable is here. It is ending in DBC. But what I want you to see is that the age variable here is not accessible anywhere outside this function here. So for example, if you try and come in main here and try to print the age, for example, we're going to say age here. If you try and access this like this, you won't be using this variable here because it isn't really accessible from the outside. If you're trying to compile this program, you're going to see a compiler error that says that age here is not declared or defined anywhere. So you're going to see age was not declared in this scope. So the compiler doesn't know what it is. Even if you try and come to the top here and, for example, say int age equals 33, for example, what you do here is not assigning a value to this age variable. You are declaring a completely different variable in the global scope of the main function. So the variable we have inside the function and the variable we have on the outside here are different. Let's try and compile this and see if it works. You're going to see that the build is good, but if we print the age, we're going to see 33, which is not what we have in our function here. You're going to see 33, and if we print the address of this, we can do that. We can say age here. So let's do that. We're going to say age. We're going to put out the age, and we're going to put out the address of this little guy. We're going to say address of age, and we're going to do the exact same thing we did in our function here. So if we do this, we will be printing the address of the outside variable here. It won't be the variable inside our function. So if we do this and say stdc out and put a simple separator here so that we can see this lines of the terminal and go down and call some function, you can try and guess what we're going to see. We're going to see the age printed out. The first one is going to be 33 here, and the address is going to be the address of this variable on the outside. And after our separator here, we're going to call the function, we're going to print 34, and we're going to see a different address. And I am going through this trouble to really try and prove that we can't access this age variable here outside this function. So this guy has no linkage. It can't be accessed outside this function here. This is what we mean by saying that it has no linkage. Let's build and run this program so that you can see the output. So the build is good. We can clear and run rooster. We're going to see, first we're going to see 33. The address is going to be ending in 020, and we're going to see 34, and the address is going to be ending in DBC. So they are different variables, and the function local variables have no linkage. That's what we mean here. You can't access them from the outside of the function, even in the file where the function was declared and defined. And you can't even access them in a separate file. For example, if we go here and set up some other file, let's do that. We're going to set up some other file.cpp. If we, for example, set up some function, we're going to do void. We're going to call this do something. If we go in and try and print the age and do something like this, for this to work, we need to include IOStream. We're going to include that. If we do this, we're going to get a compiler error, and the compiler is going to complain that it doesn't know what age is, because the age we have here can't really be accessed from anywhere other than within this curly braces where this variable is used here and declared. So I hope this is really clear. Let's try and compile and show you this compiler error we expect from this guy here. We're going to build with GCC, and we're going to see that age was not declared in this scope. The error is coming from some other file.cpp at line 4, and that's exactly here. So you can't really do this. Hopefully this drives the point home that function local variables have no linkage. Now that we have looked at this, let's focus on global variables. We're going to take out this entire thing here because we don't need this anymore. We're going to build and make sure the program is compiling correctly. You see the build is good, so we are good. We're going to go back in the main CPP file, and we're going to set up a constant variable. We can go down here and actually remove this. Now we have made our point, and we don't want this to confuse us. And we're going to go down and set up a single const variable. We're going to say const double, and it's going to be called distance. You can call it whatever you want. And we're going to put in a variable, maybe 45.8. Let's say this is the distance to go somewhere. Okay, so we have this variable here. If we want to use this variable in this translation unit, we can really use it. We can go down and say stdc out. We're going to say distance, and we're going to print the distance of this variable here. This is going to be important in a minute. And the address of this guy is going to be address of distance. We can close the left sidebar here and make sure this is saying distance, and we're going to put our new line character using ENDL here. And this is going to work. If we build and run this program, we're going to run the task to build with GCC. The build is going to be good, so we can clear and run Rooster. This is going to print our distance, no problem here. The problem is going to come if we want to use this variable in a separate translation unit. So, for example, if we go in some other file and try to set up something like this, suppose we want to access this variable from this file here, we can grab the declaration here and the definition and use that here. For example, we can say const double distance and not put in a value here, and hope that inside here we have this value we have from the main CPP file. And this is going to surprise you. Let's set up a function that is going to print this variable, but it's going to be printing what we have in this other translation unit here. So we're going to say void, and we're going to call this print distance, and we're going to say stdc out distance from other file. I think this is going to be descriptive enough. So we're going to print the distance, but we're also going to print the address of the variable here. So address of distance is going to be the address of distance. And we're going to put our new line character. This is going to work. So this is a function declared in some other file, or defined, that's what I should say. So we're going to come back in main, and we're going to put in a definition for the print distance function. So we're going to say void print distance. I think it doesn't take anything in, so we're going to do this. This is going to do. If we go in main and call that function, we're going to put in a separator. Okay, so let's try and think about what is going to happen if we run this program. We're going to print the distance from the variable we have in main, and we're going to also call the print distance function we have in some other file, and hope that it's going to access the distance variable we have in main, because we think this is a declaration for the variable we have in main, so that should bring that in. But what I want you to see is that constant variables have internal linkage by default. So we can't really access this variable from any other translation unit. If we try to do that like we do here, this is going to be a complete declaration and definition of another variable. And this is going to initialize this variable to junk. So we're going to see that junk value printed out here and not what we have in the main function. So the first printout is going to print what we have in main. It's going to print this value here. It's going to print its address in memory. And the print distance function is going to print some junk value, and it's going to print the address of that junk value, but the addresses are going to be different and the values are also going to be probably different. That's what we expect here. We're going to build this with GCC, and we're going to see a problem here. We're going to see an initialized constant distance. So if you declare a constant, you also have to declare it. So we can't even do this. And this is really good. The compiler is helpful here. So in hope to get this to work, we can try and put a pair of braces here to initialize this variable. And we're going to run the task to build with GCC. And you're going to see that the build is good. So if we try to clear and run Rooster, we're going to see that in main, we're going to have our distance here. It's going to be living at this address, but the value in our some other file is going to be 0 because we initialized that to 0. And it's going to be a completely different variable because you can't really access a constant variable or a constant global variable declared in another file. And we have a constant distant variable here. It has internal linkage. It can only be used from the translation unit where it was declared. This is the message here. So you can't really do what we are trying to do here. If you do this, this will be a completely separate variable. And we have proven that because we see the addresses to be different here. What we have in main is living at this address ending in 060. What we have in some other file is living at an address ending in 080. So they are two completely different variables. We can't really access this variable from any other translation unit. It has internal linkage. This is what we mean here. Okay, so now that we know about internal linkage, we're going to learn about external linkage. And we're going to go down and set up another variable. We are going to say int, and we're going to call this item count. Why not? And we're going to put in a value of 6. Why not? And because this is not a constant global variable, this thing is going to have external linkage. I really want you to know this. And what this means is that we can access this guy even from other translation units, and it's going to be the exact same variable. The memory is going to be the same if we print that out. And to really show this, we're going to go back in some other file and try to access our item count. But to do that, we need to mark this guy as a variable defined in some other translation unit. And to do that, we use the extern keyword. We're going to say extern. We are going to say its type, and we're going to say the name of the variable. We're going to say item count. And this is going to be a declaration of a variable that was defined in some other translation unit. This is what we mean here. So if, for example, we set up a function to print the item count, we're going to see that what we are accessing is what we have in the main function here, because this guy has external linkage. It can be accessible and used even from other translation units, like some other file here. So let's go down and do that. We're going to set up a function. We're going to say void print item count. And we're going to put up a parameter list, and we're going to say stdcout item count from other file, and we're going to say stdendl to go to the new line. We should separate these guys a little bit, and we're going to just grab this thing and use this in main. So we're going to comment out the things we had for the distance because they should be just confusing us now. And we're going to put a line to print from the main function. Let's do that. This is going to print item count that we have in main here. So let's say that this is from main, and we're going to put a separator in, and then we're going to set up a declaration for the print item count function. We can go on top here and do that. And if we have this in, we can go down and call the function. So let's do that. We can say print item count, And if we build and run this program, try to think about what we're going to get. The first print here is going to print the variable we have in main, which is declared right here. So it's going to print the item count in main. It's going to print the value, which is going to be a 6. And it's going to print the address of this variable. Because this variable is not const, it has external linkage by default. So it can be accessible even from other translation units, like some other file here. We have it declared. Again, this is not a definition of a variable. It is just a declaration of a variable we have defined in some other translation unit. So what we really have here is a way to access something that we have declared and defined in the main function here. So if we print the item count here, we will be accessing what we have in the main function. So they are going to be the same, the value is going to be the same, and the addresses are going to be the same. That's what we expect here. Let's bring this up, and we're going to build the program to make sure we get what we expect. The build is going to be good, so we're going to clear and run rooster. You see that the value is the same and the addresses in memory are the same. So this should really prove that external linkage means that you can access the variable from other translation units. And the mechanism we have is to mark the variable as external. And this is going to mean that it was defined in some other variable, but we can access it and use it even from other translation units, like we are doing in this function here. And this is really cool. But this is not just limited to non-const global variables. Even functions have external linkage by default. Okay, but for function, we don't really need to mark them as external or anything. They have external linkage by default. For example, we had declared and defined the print item function in some other file here, but we are able to access it and use that even from the main CPP file here, which is another translation unit. So functions have external linkage by default, and we can go in here and say that. But if you want to really be explicit, you can go down and say that they are external. You can come and put the external keyword in front. This is not going to hurt anything, but it's going to be just repeating yourself because they are external by default. If we try and build the program, you're going to see that this is going to build and run without a problem. So the build is good. You can put this external keyword here or you can leave it, but note that functions have external linkage by default. This is really all I wanted you to see in this lecture, learning about the concept of linkage. It is a property that you associate to your names in your C++ program. That property is going to control how accessible the name is going to be across translation units. And we had a chance to look at 3 kinds of linkage in this lecture here. We have seen that variables may have null linkage, for example, local variables to functions. We have seen that some variables have internal linkage, for example, const global variables. And we have seen that some other variables can have external linkage, like the item count here. And this should be super clear. We are going to stop here in this lecture. In the next one, we're going to zoom in on global external variables like we have this guy here. Go ahead and finish up here and meet me there.